Okay, so in this video we're talking about rational functions, and like we've done in the past videos, we're going to first talk about the parent rational function and then talk about how to transform that graph of the parent rational function into the child rational function. So a rational function is any function in the form f of x equals p of x over q of x, and p of x and q of x are just polynomials like we've seen before in earlier videos and earlier classes. The only difference is this time the bottom polynomial in our denominator, q of x, can never be 0, because I don't care if you have a fraction that's just numbers or a fraction that has polynomials in it, like we have with our rational functions, the denominator can never, ever be 0. The graph of the parent rational function is given by y equals 1 over x. So for the parent function, x cannot be 0. The x-axis is a horizontal asymptote. The y-axis is a vertical asymptote. And remember, like we talked about earlier, that an asymptote is simply an imaginary line that the graph is going to get really, really close to, but never, ever touch. The graph has two symmetrical parts, which we call branches. And for each point, x comma y on one branch, there's a corresponding point, negative x, negative y, on the other branch. When we graph these rational functions, we're going to call the graph a hyperbola. So like the graph of a quadratic function is called a parabola, the graph of a rational function is called a hyperbola. The transformed graph of the child rational function is given by y equals a over the quantity x minus h plus k. The asymptotes of this function are at x equals h and y equals k. So the vertical asymptote is going to follow the horizontal shift, and the horizontal asymptote is going to follow the vertical shift. So that's kind of backwards of what your intuition might tell you, but just remember, vertical asymptote follows the horizontal shift, horizontal asymptote follows vertical shift. To graph this function by hand, what we're going to do is actually graph each asymptote first, and then we're going to plot a couple of points on each side of the vertical asymptote, and then draw the two branches that passes through those 2 points. Just remember that our graph is never going to touch the asymptotes. So in example 28, I have a child function. It's y equals negative 2 over the quantity x plus 3 minus 1. And what I want to do, since I already have a graph, is state the domain and range. Before we do that, though, I want to talk about what pieces we have using the rule you have in your notes right here. Okay, so I have a equals negative 2, h equals negative 3, and k equals negative 1. Well, remember we said that the asymptotes of this function are at x equals h, so that means we have asymptotes at x equals negative 3 and y equals negative 1. Well, x equals negative 3 is a vertical line. That's where it is. So that's our vertical asymptote. So again, the vertical asymptote follows the horizontal shift. And y equals negative 1 is this horizontal asymptote right here. Remember, the horizontal asymptote follows your vertical shift. We know for a fact that if we did have the parent function of the rational functions plotted, that the y-axis and the x-axis would be asymptotes of this function. To verify that the vertical asymptote follows the horizontal shift, 1, 2, 3. We went 3 units to the left and got to our vertical asymptote, just like we were supposed to. To verify that the horizontal asymptote follows the vertical shift, we went down 1, our vertical shift, and we got to our new vertical asymptote like we were supposed to. In solid blue, again, is the graph of the child function. Now let's talk about the domain and range. Okay, so the domain. When we talk about the domain of any function, we're thinking about its x values, or the input values. Typically, we're using x. So as I go to the left on this branch, it looks like everything's fine. I can go as far to the left on this particular branch of the hyperbola as I want to. But on this branch, as I go to the left, I'm approaching that line, y equals negative 1. I can never get to that line, y equals negative 1, because it's an asymptote. So the domain is all real numbers, except x equals negative 3. Okay, now for the range, I'm looking at the y values of this function, or my output values. So for this branch, I look at the y values, and it's going up, 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 up. No restrictions of going to positive infinity, that's fine. But I look at this branch, I'm going up, 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 but I'm hitting this line, y equals -1. That's not good. So what that means is I'm going to be restricted in my domain. Also, as I go down on this branch, the graph is approaching the line y equals -1. It's going to get really close but never touch. On this branch, it's not restricted at all. So our range is all real numbers, except y equals -1. Okay, so that's example 28. Now you have different ways you can write rational functions. Here's another way. So all rational functions that happen to be in the form y equals a, the quantity ax plus b over the quantity cx plus d have graphs that are also hyperbolas because they're still rational functions. The vertical asymptotes occur when the x value makes the denominator 0. So again, we're looking for the x value that makes the denominator 0. That can never ever happen. The horizontal asymptote is given by the line y equals a over c, where a and c are both numbers. So whatever these coefficients are, a and c, that's where our horizontal asymptote is going to be. So in example 29, I already have this graph, but what I want to do is figure out the equations for the lines of my asymptotes. Okay, and then we'll talk about domain and range again, just for a little bit extra. All right, well, let's first find the vertical asymptote. The vertical asymptote, based on our rule, is the x value that makes the denominator 0. So what we're going to do in our scratch, we're going to say 2x minus 4 equals 0, because that x value is bad. We never ever want to touch that, because if we do, then that means the entire function is going to have a 0 on the bottom of its fraction, and that cannot happen. So we're going to say it's plus 4 on both sides, and then we have 2x equals 4. Now on both sides, I want to divide by 2, so we end up with x equals 2. This is the equation of my vertical asymptote. So right here is x equals 2. And for my horizontal asymptote, we know from our rule that it's the line y equals a over c. So what I need to do is look at my rule, at my function that's given to me, and figure out what a is and what c is. So a is, based on the pattern, it's the number in front of the x, so that has to be a 1. It's kind of hidden, but it's understood to be 1. And then c happens to be 2. So that means my horizontal asymptote is at 1/2. Y equals 1/2. Okay, now we have all the information we need to talk about the domain and range of our child function. So let's start off with the domain like we typically do. And we're going to think about the x values. Now we have to be sure to check out each branch. Let's do the bottom branch first. As I go to the left, I can keep going to the left as far as I want to, no problem at all, no restrictions. The top branch, though, as I go to the left, I get restricted by this green asymptote, x equals 2. So there is a restriction I need to keep in mind when I'm talking about my domain. Now for each branch, let's go to the right. Well, with this branch, I can go right until I get to the line x equals 2. So since it's an asymptote, I can never hit x equals 2. I can get really close, but close isn't good enough. With the top branch, I can go as far to the right as I want to, all the way up to positive infinity. So what that tells me about the domain is all real numbers, except x equals 2. Now let's talk about the range. Again, we're going to look at the y values, and we have to look at both branches. So let's go about going down first. So with the bottom branch, I can go down as far as I want to, all the way to negative infinity, no restrictions there. With the top branch, however, if I start going down, I can get as close to y equals 1/2 as I want. However, that's as close as I can get. I can never touch 1/2 or go anywhere past it. So I am restricted, so I need to keep that in mind. Now let's try to go up with each branch. I'm going to start with the bottom branch again. As I go up, I get really close to that line y equals 1/2, but I can never quite cross it, so I have another restriction. And with the top branch, I can go all the way up to positive infinity, no problem at all. So the range is all real numbers, except y equals 1/2. Okay, so we've seen two ways to write the child function of a rational function. One way, it was very easy to tell what our horizontal and vertical asymptotes should be. They just follow the horizontal and vertical shifts. Here, in this format, we had to do a little bit of scratch work to figure out what our vertical and horizontal asymptotes were. Other than that, that's it for this video. If you got questions, please let me know.